In section 5.4, we're looking at some alternate situations you might find yourselves in when solving systems of equations. Want to start with a reminder that lines that are parallel are lines which have the same slope. So that would be a graph that looks like the one down here in the middle. Um, we know from solving systems up to this point that when we look for a solution to a system, that is that point that's on both lines, or the point of intersection of the two lines in a two equation system. Well, sometimes if lines are parallel and don't intersect, we have a system which has no solution. They never intersect, so there are no points which are on both lines. We could also have a system where when we simplify both equations, that they end up being overlapping lines and also not, and therefore every point that's on one line would also be on the second line. That's a situation where we have infinitely many solutions. So we're going to look at when do we have one solution, no solutions, and infinitely many solutions, and what does that look like? When you're solving systems by graphing, um, if you have a different slope and a different y-intercept, those are lines that intersect, so they have one solution. If the lines have the same slope and a different y-intercept, that means that they're parallel and not overlapping, so there's no solutions. And if the slope and y-intercept is the same thing, then that means that the lines are overlapping and there are infinite solutions. When we're solving algebraically, that means, and we find a number for x and then can substitute that back in and determine a number for y, that means we have one solution or one point. But if we're solving and we end up with a false statement, for example, 4 equals 5, that's not true. That's going to tell us that our lines are parallel and never intersect, so therefore there's no solution. Similarly, if we're solving and our variables are all eliminated or canceled, we end up with a true statement like 3 equals 3. That indicates that we have infinitely many solutions. So let's take a look at a couple examples. As you're solving systems, we want to consider which method works best to solve a system. When I look at this first example, 2x plus 2y equals 8 and x equals 2 minus y, I think that this system sets up nicely to use substitution because we have x equals some stuff here. X equals 2y, so I could use that to substitute into the first equation for 2x, so, or for the x value. So if I were to do that, then 2 instead of x, I can use 2 minus y, and then finish writing the rest of the equation. Now I can solve for y. So going through steps that we know, first we want to distribute. So 2 times 2 is 4. 2 times negative y is negative 2y. And then bring down your 2y and 8. Now I have like terms that I can put together. Um, So negative 2 and positive 2 adds to 0. So those cancel. They add to 0. So they're um, so I can cancel those out. And I end up here with 4 equals 8. Well, what does that tell me? That tells me that I can't continue solving and I have to decide between infinitely many or no solutions. Well, we want to think, is this a true statement? 4 does not equal 8, so that is a false statement. Therefore, this is a system that has no solution. So the end result is no solution. If I were to graph these two equations, then I would see that they're parallel lines. So let's take a look at the graph there. Um, So if I'll turn on the first line, 2x plus 2y equals 8 is there in red. and then x minus 2y, that graph, I can clearly see that these lines are parallel and they're not intersecting, so no solutions makes sense because there's no intersection points. When I look at the second example here, this makes the most sense to solve using elimination because both equations are in standard form. So if I want to choose a variable to eliminate, um, let's say I want to eliminate x's, I would need to multiply the top equation by negative 2 so that I have a negative 2x and a positive 2x. So then that top equation will become negative 2 times x is negative 2x, negative 2 times negative 4y is positive 8y, and negative 2 times 1 is negative 2. So now that I have opposite coefficients on x, I can add those two equations together. 2 plus negative 2, that makes 0. Negative 8 plus 8, that also makes 0, so I have 0 on the left side. And 2 plus negative 2, that also makes 0. So, well, all of my variables canceled. So now I'm thinking, is my statement true or false? Well, 0 equals 0. That is a true statement. So therefore, this system has infinitely many solutions. So when you're solving systems, sometimes we'll end up in a place like we have been up to this point where we can actually solve and get values for x and for y. Sometimes you're going to run into systems where every variable adds to 0 and you have no variables left. In those cases, you have no solution or infinitely many solutions. So just an additional wrinkle to your solving of systems. Thank you.